Hello and welcome back. We're going to graph number 3 together to get used to A, H, and K. So for number 3 here, you first want to identify your base. So 3 here represents a base of 3. The other numbers then would be your A, your H, and your K. So for your A value here, you have an A value of 2, which is a vertical stretch. Your H value, notice how it's a -1 here. I'm going to write a +1 for your H value because it moves your graph right 1. Your K value here is +2, which means your graph is going to go up 2. So now what we're going to do is we're going to go ahead and create our table. Now we're going to put our table of values on the outsides here. So our X values were -1, 0, and 1. Your Y value is the one that we keep on saying you need to memorize, is going to be 1 over your base, which in this case is 1 over 3, 1, which stays 1 for right now, and then your base, which is 3. Now in the past, we just kind of graphed those, did our line here, and off we went. But the problem is that we need to actually move things all around based off of our stretch, our right, our up. So anything that is your X value, with your X value, which is your H right now, is going to apply to your X value over here. So for every single exponential graph, after you create -1, 0, and 1, whatever your H is, you're going to add that to your X. So my X values here need to move right 1, so we're going to take and add 1 to each of these. So -1 plus 1 is 0, 0 plus 1 is 1, and 1 plus 1 is 2. Now your A and your K are going to go to your Y values. So upon your Y values, every single time after you create your 1 over B, 1 and B values here, you're always going to multiply by A, and then you're going to add K. So for each of these ones, we are going to multiply by 2, and then add 2 to them. So the first 2 is coming from your A value, so times 2, and then the +2 is coming from your K value, +2. So for each of these, we're going to do times 2, then +2. So 1/3 times 2 is 2/3, +2 is 2 2/3. 1 times 2, and then +2. So 1 times 2 is 2, and then add 2 to that, and you get 4. We're going to do 3 times 2, and then add 2 to that. So we get 6 plus 2, which is 8. So if we look at this, 0, 2 and 2/3 would be up here. 1, 4 would be over here. And 2, 8 would be up here. Now, if you think of what your graph would have looked like initially before you moved anything around, don't draw this, but this would have been what your graph had looked like prior to moving it all around with the 1 over 3, 1 and 3. Imagine moving that right 1, stretching it by 2, and moving it up 2. That's our new graph that we have up here. So before we connect this, what I'm going to do is I'm going to go ahead and I'm going to identify my asymptote. My asymptote is always going to match whatever my K value is. So as a reminder, your asymptote is Y equals your K value. Now my K value here is 2. So my asymptote is going to be Y equals 2. And right away, you can go ahead and graph that on your graph grid. And then once that's in there, then you can go ahead and graph your exponential function here, getting close to that asymptote, but never touching it. Our graph here looks like exponential growth. Our base here was 3, so that all matches up. It is growth. Our domain is -infinity to +infinity. And your range, your graph from low to high, starts at 2, but it doesn't ever touch 2, and it goes up for forever. So this is going to be how we tackle all of our exponential graphs. Tomorrow we're going to practice more with this, so you'll get used to it a lot more then. Today, most of our practice is going to be mainly just creating a table of values like this one to see if you have exponential growth or exponential decay. So thank you very much for listening. I hope this helped, and tune back in tomorrow to see the rest of this. Thanks.